Hello and welcome to Atomic Theory for Akshay Patel, Rushay Vyas, and Ishi Chowchow. So the atomic theory started when Democritus decided that all matter should be made of small particles called atomos. This was because he thought that all matter, there must be some limit to how small it could be. John Dalton took this further, and he said that matter is made of atoms that can also combine. J.J. Thomson started to discover more aspects of the atom. He discovered the electron and decided that this is a model. This looks like plum pudding, where the majority of the pudding is positive and there are negative electrons inside of it. Ernest Rutherford corrected this, and he said that there should be a nucleus, a positive nucleus inside with electrons around it. And the atom is mostly empty with the space you can see here. James Chadwick discovered the neutron and said that the nucleus had protons that were positive and neutrons that were neutrally charged, with negative electrons surrounding it. Robert Millikan decided that the electrons should have a charge and also a mass, and he calculated this using this oil drop experiment. Henry Moseley took this further and applied it to the periodic table, taking the number of protons as the atomic number and organized the periodic table that way. Finally, Niels Bohr decided to organize the electrons based on shells instead of just randomly around the atom. Let's talk about the atom itself. So the nucleus is the center of atom, and it's made up of protons and neutrons. Protons have positive charge and weigh 1 atomic mass unit. Neutrons have no charge and weigh also 1 atomic mass unit. Electrons are negative charge and weigh literally nothing. So the nuclear symbol for an element will be like this. The mass number, which is the number of protons plus the number of neutrons, and then the number of protons at the bottom. This atomic number at the bottom will decide the identity of the element. This mass number will just decide, well, the mass number. Let's see. Okay, on the periodic table, it's represented this way. It shows only the atomic number, not the mass number. You will not find the mass number on the periodic table. You will, however, find the atomic mass, which is something different. Isotopes tie into this. Isotopes are the same element, which means they have the same number of protons, but they have a different amount of neutrons. Each isotope has a percent abundance in nature. The one with the highest percent is the most common and closest to the average atomic mass, which is shown on the periodic table, which, if you remember, is this right here. Let's talk more about this. Mass spectroscopy is a way to calculate the average atomic mass. It produces spectra of isotopes, which means that, let's see, magnesium 24 is the most abundant. 79% of all magnesium atoms in the universe are magnesium 24, which means they have a mass number of 24. 10% have a mass number of 25, and 11% have a mass number of 26. To calculate the average atomic mass of magnesium in general, we just take the percent abundance, which would mean 0.7, and not 79%, just do 0.79 times this number right here, 24, plus 0.10 times 25 right here, plus 0.11 times 26 right here, and then that will give you the average atomic mass of magnesium. So there you have it. If you have any more questions, please feel free to ask that history of you. Potato.